SAT, classwork number 12, question 1. The population of bacteria colony doubles every 48 hours. How many hours will it take for a 100 bacteria sample to grow to 1,600 bacteria? To solve this problem, it is an exponential equation, doubling every 48 hours, but simply make a table. Starting at time 0, you have 100 bacteria, and then every 48 hours in the left column, write down the multiples of 48. The bacteria is doubling during that time period. So after 48 hours, there'll be 200 bacteria. After another 48 hours, it will double again to 400 bacteria, and so on. Following this doubling pattern, it takes 4 doublings for it to reach 1,600 bacteria. 4 times 48 is 192 hours. The correct answer is C. Question 2. A radioactive element has a half-life of 7.1 times 10 to the 6 years. Approximately how long will it take for a sample of 100 grams to decay to 75 grams? Well, this problem can be solved by plug-in. Set up the period K equals 7.1 million years, so 7.1. The initial amount is 100 grams, and the final amount is 75. The decay rate is half of the life, meaning that after 7.1 million years, there'll be half of the sample left. So the amount, the R rate will be 1 minus a half, or 0.5. Plugging in, we have for choice A, after 2.945 million years, we'd take a half and raise it to the 2.945 divided by 7.1. Then we would have 75.012 grams left, which was the correct answer. Choice B was 5.346 million years. If you divide that exponent by 7.1, you'd get that we'd have 59.339 grams left. Choice C is the half-life. So if we do 100 times a half to the 7.1 divided by 7.1, we're really doing 100 times a half to the first power, which is why we have exactly 50 grams left. Because 7.1 million years is the half-life. Then if we go beyond the half-life, 8.615 million years in choice D, notice that we have less than half the sample left, because 8.615 divided by 7.1 is an exponent larger than 1. So we will have 43.126 grams remaining of our initial sample. The correct answer was A. For question 3, a bank offers college loans with 14% annual interest rate. How much will a student owe after borrowing $50,000 for a 4-year college tuition 5 years after receiving the loan? Well, here the initial amount is $50,000, the time is 5, and the rate is 1 plus 14%, because the amount of the loan will grow. Doing the exponent term separately, we see that 1.14 to the 5th power will be a multiple of 1.92541. Multiply that by 50,000, and we get the loan will now owed to the college will now be $96,270.73. The correct answer was D. Question 4. A refrigerator loses 10% of its value each year after it is bought from the store. How much is a $1,750 refrigerator worth after 6 years? Well, for this problem, set up the initial amount as $1,750. And since the value is going down, it's a decay problem. So do 1 minus 10%, and we have 0.9 for the rate. That's the base of the exponent. The amount of years is 6, so t equals 6. So plugging in, we have 1750 times 0.9 to the 6th power. 0.9 to the 6th power is 0.531411. So it looks like we'll have a little more than half left of the initial value when it was bought fresh at the store? The correct answer was C, $930.02. Question 5. An auction house claims that the painting by a renowned master painter increases in value every year by 3%. If a painting is auctioned for $1 million, how much will this artwork be worth after 25 years? Well, the initial value is 1 for 1 million. The rate is 1.03, and the time is 25. Multiplying this exponent, we have 1.03 to the 25th is 2.094. Times 1 means that the painting in 25 years will be worth $2,094,000. The correct answer is D. Question 6. Representing the sunflower plant growth formula with the equation, the height at time t is 3 times 1.1 to the t minus 5. So this formula approximates the fast growth of a sunflower for a reasonable number of weeks. So it says, what will be the approximate sunflower height after 20 weeks using this approximation formula? Plug in t equals 20. Then we have 3 times 1.1 to the 15th power, which will be 3 times 1.477, and the height at 20 weeks will be approximately 12.54. The closest answer to that is D, 13. Question 7. The graph shows 4.05 to the x minus 2 at the right. What is the value of f of 0 minus f of 2? For this problem, plug in for f equals 0 and f equals 2. F of 0 is 4 times a half to the negative 2, which is 4 times 4, or 16. The function evaluated at 2 will be 4 times a half raised to the 0 power. So then we'll have 4 times 1, or 4. Finally, the difference of these values, 16 minus 4, will be 12. The difference is 12, D. Question 8. A sector spider investment is growing steadily at 5% each year. How much more would a $10,000 sector spider be worth after 14 years than after just 4 years? Well, plugging in for those separate values, we have the initial amount is 10,000 invested. The rate is 1.05. F of 14 is 10,000 times 1.05 to the 14. That exponent will be a multiple of 1.9799. So after 14 years, you'll have $19,799, almost double. The time after 4 years would be 1.05 to the 4th power as the multiple, which is 1.2155. So you'd have about $12,155. The difference, 19,799 minus 12,155, $7,644. The correct answer was A, it's closest to 8,000. Question 9. Calculator company believes its current model will be worth nothing in 10 years. So they write the formula of the value at time t is $100, that's the starting amount, minus 100 times 1.4 to the x minus 10 for the value of the calculator over a 10-year period. How much more is the calculator worth after 3 years than 8 years? Interesting. So plugging in for 3 years and 8 years, we have for v of 3, will be 100 minus 100 times 1.4 to the negative 7, which works out to be $90.51. That same calculator bought at the store for $100 after 8 years will be 100 minus 100 times 1.4 to the negative 2. So it'll be worth $48.98. Okay. The difference, 90.51 minus 48.98 is $41.53. It really falls off fast after 8 years, because it's still worth half its amount after 8 years. It's an interesting formula. Okay, last one. Question 10. Veronica places $1,400 into an investment that earns 10% interest every 3 months. But after 2 years, she realizes that she's incorrect and that she has $211 less than she should have. She realizes she has the wrong interest rate R written down. Which equation is the incorrect formula for the investment? After 2 years. Well, figure out the correct amount first. 1,400 times 1.1 for the rate, scoring at 10%. Raised to the compound. It compounds every 3 months. So that's 4 times a year for 2 years. So that's raised to the 8th power. Then you'll have 1,400 times 1.1 to the 8, or 1,400 times 2.1435. So that money, which has more than doubled, it's more than twice the amount, will be $3,001.02. Then go through each formula on the right, plugging in for t equals 2. And you'll see that choice A, the final amount, 1,400 times 1.09 raised to the 8th power, will be 1,400 times 1.99, 256, which will be $2,789. That is a difference of $211. The correct answer is A. So the error was she computed at 9% growth and not 10%. So after 8 compounds, that's $211 more. Okay. Correct answer was A. I hope this video was useful to you in preparing for exponential equations on your upcoming SAT exam. Thank you for watching my video.